Okay, we're going to continue our discussion of curve sketching. This time we have a regular polynomial. So the domain of a polynomial, of course, is just all real numbers. There's no denominator. There's no even radical, so it's just all real numbers. To find the X-Intercept, we set this function equal to 0. Let's look at that. 10x to the 5th. I knew something was wrong. 10x to the 5th minus 20x to the 4th plus 10x cubed. Okay, so this should be a 5. Okay, so we'll factor that. What they all have in common is they all have a 10 and they all have an x. So I'm going to take a 10x cubed, the smallest x is 3, take that out of there. And what that leaves me with is x squared minus 2x plus 1. So factoring that further, we would get 10x cubed times, the factors of 1 that had to give me 2 are 1 and 1, same sign, both negative. So if we set those to 0, we're going to get that 10x cubed equals 0, and we're going to get that x minus 1 equals 0. Divide both sides by 10, x cubed would equal 0. Take the cubed root of both sides, so x would just equal 0, and over here x would equal 1. So the definition of X-Intercept is you set your y part to 0, so that's why I set the function to 0. So I'd have an X-Intercept at 0 with y value 0, and also at 1 with y value 0. To find the Y-Intercept, you set x to 0. So for this function up here, if I say f of 0, I get 10 times 0 to the 5th minus 20 times 0 to the 4th plus 10 times 0 to the 3rd, which would just be 0. So my Y-intercept is 0, 0. My vertical asymptote, remember you set your denominator equal to 0. There's no vertical asymptote since there's no denominator. Your horizontal asymptote deals with powers. Obviously, the highest power is on the top since that's your only power. So, since the highest power is on the top of a horizontal asymptote, that rule is when your highest power is on the top, there is no horizontal asymptote. So that moves us on along to increasing intervals. To find the intervals where the function is increasing, you find the derivative, which I've done here. I also went ahead and factored it. So to find increasing intervals, you're going to see where does my derivative equal 0 and where is my derivative undefined. Well, there's not a denominator, so you don't have to worry about the undefined part. The numerator is this factored piece here, so I can set 10x squared equal to 0, I can set 5x minus 3 equal to 0, and I can set x minus 1 equal to 0. So x would equal 0, x would equal 3/5, and x would equal 1, and these are my critical numbers. So I'm going to put these on a number line, dividing the number line into intervals. I'm going to be plugging these into the derivative. I'm going to choose to plug mine into the factored part, but technically you could plug your test points into any of the parts. This one was just a little bit easier for me. So a number that I might have over here, I might choose -1. In between 0 and 3/5, I might choose 1/5. In between 3/5 and 1, I might choose 4/5. And in between 1 and infinity, I might choose 2. Okay, so if I plug -1 in, I tell you, let me put this on pause That way you don't have to watch all the plug-in part. Okay, so when I plugged in my test points, here's how they looked, and I did them in different colors where you could see them. So the first thing that I did was I plugged in -1. So I said 10 times -1 squared, so that gave me a positive result. In the middle, you got a -5 minus 3, so that's a -8. And on the back side, you got -1 minus 1, which is a negative. So remember that two negatives make a positive, so this would be positive, and you already had a positive. So that's going to be a positive result. So we're increasing along this mark here. So in my blue interval, you see I plugged in the number 1/5. So 10 times 1/5 squared. And again, you're just plugging it into this derivative right here that I've underlined. 10 times 1/5 squared. And then you had 5 times 1/5 minus 3, and then 1/5 minus 1. Well, 10 times 1/5 squared is a positive result. 5 times 1/5 would be 1. The 5's cancel out and leaving you with 1. 1 minus 3 is negative, and 1/5 minus 1 is also negative. So again, you have two negatives making a positive, and you have a positive on the front, so that interval is also positive. Moving on to the orange interval, you're plugging in 4/5. So 10 times 4/5 squared, all of that's positive. 5 times 4/5, the 5's would cancel out, leaving me with 4. So you'd get 4 minus 3, which is positive. And 4/5 minus 1 would be a negative. So in this one, you would have a positive in the front and a negative in the back, which leaves you with a negative result. So I'm decreasing here. And the last one, I'm plugging in 5. I could plug in 5, sorry, but I'm plugging in 2. So 10 times 2 squared would be positive. 5 times 2 is 6. 6 minus 3 is positive, and 2 minus 1 is positive. Everything's positive, so we're increasing along this interval. So I'll write those on the previous page. Okay, so in these increasing, decreasing areas, you'll see that we went from positive to negative right at 3/5, so that made that one a max. And we went from negative to positive right at 1, so that one made it a min. So I put my intervals of increasing in green, my intervals of decreasing in orange, and I found my local max, which was at 3/5. To find the y value, I plugged into the original, and I don't need additional points, or it doesn't cross an asymptote since there's not one. So all I have to do is go on my graph and put my points. So I have 0, 0, and I have 1, 0. Okay, that's not going to give me enough room. So let me back up for a second and see if I can fix this graph. Let's try this again. Alright, so I have points at 0, 0, and I have points at 1, 0. So those are my X-intercepts. The graph also crosses the y-axis right here at this point, so that's a point in both locations. I have a local max at 3/5, 1.78. So 3/5 is around 0.6, so I go up to 1.78. That should be somewhere right in here. And I have a local min at 1, 0, which is this blue dot here. Now, we only have those 3 points, but we can graph it based upon those 3 points. I know I'm increasing all the way to 0. So that means it's going to be coming somewhere like this, and it's going to come to 0. I'm increasing there. It says I'm also increasing from 0 to 3/5. So I keep on going here. It says I'm also increasing from 1 to infinity. Well, 1 is on the blue point. It's increasing from 1 to infinity. I'm decreasing from 3/5, that's my red point. I'm decreasing from 3/5 to 1. I know that's a tough sketch, a rough sketch rather, but that's what it looks like. It's increasing all the way to the red dot, and then it's going from there. And that's how your graph would look. Now looking at the last one, what you'll notice is that all of the facts have been given to you, and all you have to do is graph it based upon those facts. So let's go ahead and work with that one. I see I have a y-intercept at 0, 2, so that's going to put me right here. I don't have any horizontal or vertical asymptotes. I do see extra points. See, I have a local max at 1, 6. So that blue point's going to be a max. I have a local min at 3, 2. So that green point's going to be a min. And I also have an inflection point at 2, 4. Remember, for an inflection point, that's the second derivative, where the second derivative equals 0, and then you can make a number line for that. Now, using my rainbow of points here, we can hopefully sketch a graph. It tells me that my graph is increasing all the way to 1. So that means 1 is at the blue point. So we're going to be increasing all the way through the yellow to the blue. And then I'm decreasing from 1 to 3. And then I'm increasing. I think that should say 3 to infinity. Let's change that up. I'm increasing from 3 to infinity. And that's what the graph should look like. Well, let's try that again. There we go. So that's what our graph should look like. And that's it for curve sketching.